All right, everyone, get ready. Today we're taking a deep dive into multimodal AI.
Oh, yeah. Multimodal AI is really heating up right now.
It is. And specifically, we're going to be exploring transfusion,
Okay.
which is this new model that is making waves in the machine learning community.
Interesting. I'm excited to hear more about this transfusion.
I think you're really going to like this one.
All right.
Because, imagine a single AI that can write like Shakespeare A&D paint, like a digital Da Vinci.
Wow. Wow.
That's what we're unpacking today.
That's incredible. And that's what multimodal AI is all about, right?
Exactly.
It's this really ambitious goal of creating AI that can understand and generate both text and images, not just one or the other.
Yeah.
Traditional AI models, they're like specialists. They excel at either language processing or image processing, but rarely both.
Right.
And Transfusion, this new model, is trying to break down that barrier.
It really is. And I've been reading this research paper from Meta.
Okay.
And they've called this creation, their model, Transfusion.
Catchy name.
It is. And it's a totally new way to train a single AI on both text and images without sacrificing quality in either one.
Without sacrificing quality. That's impressive. How do they pull that off?
Yeah. It sounds kind of like magic.
Right.
How do they do it?
Well, it might seem like magic, but it's really a clever combination of two powerful techniques.
Okay.
Language modeling and diffusion.
I've heard of both of those. Now, language modeling is like what our phones do with predictive text. We're
Exactly.
constantly guessing the next word,
Yes.
trying to figure out what we're going to type.
Yeah, Transfusion uses that same predictive power to learn the intricacies of language. The grammar, the style, the flow.
And diffusion?
Yeah.
That's all about image generation.
It is. Picture this. Imagine slowly corrupting an image by adding noise until it's just static.
Okay.
Diffusion models are trained to reverse that process, essentially learning to paint by removing the noise step by step.
Wow. So it's like one part of transfusion is devouring books to master language, while the other part is meticulously studying the art of painting.
It's a great way to think about it.
But it's all happening in the same AI brain.
Exactly. And that's what makes it so remarkable.
This is wild.
It is. What's really key to Transfusion's success is how it represents images.
Okay. How so?
So instead of clumsily converting images into word-like tokens,
Right.
which can lose a lot of information,
Yeah.
it treats images as continuous vectors.
Okay.
And this preserves much more of the visual richness and detail.
Oh, that makes sense. So it's not trying to force-fit images into a language model?
Right.
It's actually working with them in a way that respects their visual nature.
Precisely. They also use something called VAEs.
VAEs?
Yeah, variational autoencoders, which are like super smart compressors.
Right.
They can squeeze down the image data without losing too much important information.
So we have language modeling, we have diffusion working together,
Yeah.
each tackling its own specialty.
Yes.
But text and images, they're processed so differently. How does transfusion reconcile those differences?
That's where the real ingenuity comes in.
Yeah.
Transfusion uses different attention patterns for text and images.
Attention patterns, what do you mean by that?
So for text, it processes information sequentially, word by word, like we read a sentence.
Yeah, makes sense.
But for images, it takes in the entire picture all at once, capturing the relationships between different parts of the image simultaneously.
Oh, that's so cool. It's like the difference between reading a novel and appreciating a painting.
Exactly. You got it.
You experience them in totally different ways.
You do.
Each has its own unique kind of rhythm and structure.
That's a fantastic analogy.
So transfusion, it doesn't just sound good on paper.
Right.
Does it actually work?
It does. What's really remarkable is it actually delivers outstanding results.
If I give you the details, how good is it?
Well, on standard image generation tasks,
Okay.
Transfusion consistently outperforms some of the biggest names in the game,
Like who?
like DALL-E 2 and SDXL.
Really? You're telling me this new model is already outperforming some of the most famous AI image generators?
It is, and it gets even more intriguing.
Okay.
Transfusion is incredibly efficient at learning text,
Mm-hmm.
even surpassing models that are specifically designed only for text processing.
Wait, it's better at understanding text by looking at pictures.
It seems counterintuitive, but the evidence is compelling.
Wow.
It suggests that Transfusion's ability to work with both visual and textual information might be leading to a deeper, more generalized understanding of language itself.
That's incredible.
It is.
We're just scratching the surface here, right?
Oh, absolutely.
This AI can do more than just generate pretty pictures and write eloquent prose?
Much more.
There's got to be more.
You're right.
Tell me more.
You're absolutely right. The researchers behind Transfusion, they didn't stop at just generating images and text separately. They also wanted to explore Transfusion's potential for...
For what?
Image editing.
Like actually editing existing images based on text instructions.
Yeah.
That sounds like something straight out of a sci-fi movie.
It might sound futuristic.
Yeah.
But Transfusion is making it a reality.
Wow. So how do they do that?
Well, they fine-tuned the model on a relatively small data set of image edits, and the results were really astounding.
Astounding, huh?
Yeah.
So Transfusion was successfully able to edit images based on just simple text prompts. That's incredible. So I could take a photo and just tell this AI to, say, change the color of someone's shirt.
Right.
Or add a rainbow in the background.
Exactly.
And the implications of this are just massive.
They are.
Imagine a world where photo editing is as simple as describing what you want.
That's the goal.
That's incredible. And I bet the applications go way beyond just photo editing, right?
Oh, absolutely. Image manipulation at this level has enormous potential in fields like design, art, and even scientific visualization.
Yeah. So we're talking about a whole new way to interact with and shape the visual world.
That's right.
This is just the tip of the iceberg, isn't it? What other mind-blowing applications are hiding beneath the surface?
There's a lot more to explore, but before we dive deeper, let's take a moment to recap what we've learned so far about Transfusion.
Okay, yeah, rewind time.
So Transfusion is a single AI model trained on two seemingly distinct tasks: predicting the next word in a sentence for text, and reversing noise corruption for images.
Right.
But the magic really lies in how seamlessly it weaves these two tasks together, right?
Right. So Transfusion uses separate encoding and decoding layers to handle the text and images individually. But it's still being trained as one unified whole.
That's right.
And this clever architecture,
Yeah.
coupled with techniques like bidirectional attention for images and VAEs for efficient image representation,
Exactly.
that's what allows Transfusion to achieve such amazing results.
Precisely.
Right. And not only does it excel at text generation and image generation,
Yeah.
but it's also showing a lot of promise in even more complex tasks like image editing.
It is. It's really exciting.
It's like we've taken this giant leap towards a future where AI can understand and manipulate both language and visual information and do it with equal fluency.
You got it.
This is truly groundbreaking research. It feels like we're witnessing a paradigm shift in AI,
I think so too.
where models are becoming more versatile,
Yes.
more adaptable,
Definitely.
and more capable of understanding the world in a way that mirrors our own multimodal human experience.
Exactly. And this research is just the beginning.
Oh, there's more.
There's so much more to explore.
Okay. I'm already hooked. So what other surprises does Transfusion have in store? Tell me more.
I will. Okay, so to really see how groundbreaking Transfusion is,
Okay.
the researchers, they put it head-to-head with another multimodal model
Okay.
called Chameleon.
Chameleon. Interesting name.
Yeah.
How does Chameleon approach this whole multimodality challenge?
Well, Chameleon takes a different path.
Okay.
Instead of preserving the visual nature of images, it converts them into these discrete tokens.
Tokens.
Yeah, kind of like breaking down a picture into individual words.
Okay.
Then it feeds this combined stream of text and image tokens
Okay.
into a standard language model.
So it's basically treating images as just another form of text, trying to make them fit into that language mold.
You got it.
Interesting approach.
Yeah, but here's the thing.
What?
Across a whole bunch of tests,
Okay.
Transfusion consistently outperformed Chameleon.
Really?
Yeah.
On all the tests?
Yeah, whether it was generating images, writing captions for images,
Oh.
or even on tasks that were purely text-based.
So Transfusion wins.
Transfusion wins.
What do you think gives Transfusion that edge?
It all goes back to how Transfusion represents those images.
Okay.
By keeping them as continuous vectors, it holds on to much more of that visual information that gets lost when you try to chop images up into those discrete tokens.
I see.
It's like trying to describe a stunning sunset with only a few words versus capturing it in a high-resolution photograph.
Yeah, you're going to miss some of the nuance and the emotional impact
Yeah.
when you reduce that complex visual scene to just a few words.
Right. And what's really fascinating is this difference in image representation.
Yeah.
It seems to impact Transfusion's ability to process text, too.
Wait, are you saying that a model trained on both images and text can actually learn text better than a model that's only trained on text.
That's what it looks like.
How is that possible?
It is one of the most surprising findings of this research.
It is, yeah.
One theory is that by handling that complexity of visual information, transfusion develops a more robust and flexible understanding of language itself.
Like learning to appreciate the subtleties of poetry by also studying the brushstrokes of a masterpiece.
Exactly.
So cool.
It really challenges how we think about AI.
It does, yeah.
Where we assume we need specialized models for each type of data.
Right.
But the researchers didn't stop at just comparing transfusion to other models.
Okay.
They also wanted to understand what makes it tick.
Oh, how do they do that?
They did a bunch of ablations.
Ablations?
Yeah, basically carefully dissecting the model.
Okay.
To see how different parts contribute to its overall performance.
So they're like AI surgeons?
Like a controlled experiment.
Yeah.
You isolate variables and see the impact.
Gotcha.
And one of the interesting discoveries was the importance of bidirectional attention for images.
Bidirectional attention for images.
Remember how we talked about transfusion allowing each image patch to see all the other patches at the same time?
Yeah, like each piece of the puzzle gets to look at the whole picture.
Exactly. And that ability is crucial for transfusion success in those image-related tasks.
I see.
When they restricted the model to only using a limited form of attention for images, performance on tasks like image generation, it really tanked.
It's all about seeing the whole picture.
It is.
You can't just treat text and images the same way if you want the best results.
You can't.
Another really fascinating ablation explored the impact of patch size.
Patch size.
Remember how transfusion breaks down images into smaller chunks?
Right.
Called patches?
Yeah, those are compressed representations of small sections of the image.
Right, and the researchers found that there's this balance between patch size and performance.
There is, yeah.
Larger patches mean fewer patches overall, which could make the model faster.
Yeah, and more efficient.
But I imagine you also lose detail if the patches are too big.
Exactly. And they found that while larger patches worked okay for some tasks, they caused a drop in performance for tasks that needed a more nuanced understanding of the finer visual details.
So it's all about finding that sweet spot.
It is.
Between efficiency and the level of detail that needs to be preserved.
Classic trade-off.
Yeah.
They also messed around with different ways to encode and decode those image patches, comparing a simpler approach to a more complex architecture. Based on something called U-net blocks.
I'm guessing the U-net blocks won.
You guessed right. Even when they scaled the model up to a massive 7 billion parameters.
Wow, that's huge.
The U-net encoding and decoding, they still provided a significant performance boost.
So choosing the right architecture really matters.
It does. You can't just use any old encoding and decoding scheme.
No.
And expect it to work.
Makes sense.
Finally, they investigated how the amount of noise added during that diffusion process affected transfusion's ability to generate image captions. Remember, diffusion models are all about starting with just noise and gradually refining it into a coherent image.
Right. So how much noise was too much noise?
Interestingly, they found that limiting the noise level when showing images with their captions actually improved the quality of those captions.
So less noise, better captions.
Yeah, it's like the model was able to focus better on the important visual information when the noise wasn't too overwhelming.
So there's a sweet spot for noise, too.
There is. All of these ablations really highlight how important it is to understand the ins and outs of multimodal learning. It's not just about putting different models together. You really got to think about how those different data modalities interact. How to represent them well and how to fine-tune that architecture to get the best results.
Makes sense. It's like a dance between art and science.
It is.
This is all very technical, though. How does transfusion actually perform against those top image generation models?
That's the question, right? To find out, they trained this colossal 7 billion parameter transfusion model.
Huge.
On a massive data set of text and image data.
And
how did it do?
On a benchmark called Geneval, which measures the quality and accuracy of image generation, transfusion was comparable to top-performing models like Deep Floyd.
Deep Floyd, that's a big name. It is. And it even did better than some previously published models like SDXL.
Wow.
Of course, it's important to remember that it still fell behind some of the absolute best models, like SD3.
Okay.
But those often use additional techniques,
Right.
like synthetic captioning,
Okay.
to boost their performance even further.
So it's not quite at the very top, but it's up there with the heavy hitters.
It's holding its own.
And this transfusion model wasn't just about image generation, right?
No, not at all.
It could generate text, too.
It could, and it did that on par with dedicated language models,
Wow.
like Llama,
Okay.
which were trained on the same text data but without any images.
That's amazing.
It is. It shows the power of this multimodal approach.
Yeah.
It's like transfusion is learning this deeper representation of information that goes beyond the boundaries of just text and images.
Super cool. But they didn't stop there, did they?
They did not.
They took it even further.
They pushed it further, yeah.
Hey, tell me more.
They wanted to see if transfusion could tackle a task
Yeah.
that wasn't even part of its initial training. Image editing.
Image editing, you mean like editing existing images based on text?
Exactly.
We touched on this before.
Yeah.
But how did they actually do it?
They took transfusion and fine-tuned it,
Okay.
specifically for image editing, using a relatively small data set.
A small data set. That's surprising.
It is.
You usually need tons of data to fine-tune these big models
You do.
for new tasks.
It seems transfusion's experience with both text and images gave it a head start.
Okay.
It was able to adapt to this new challenge quickly
Okay.
without needing a ton of extra training data.
So how did it actually perform?
They tested it on this thing called the ImuEdit test set.
ImuEdit.
Yeah, it's known for its tough image editing tasks.
Okay.
And transfusion was editing images based on the text instructions.
Give me some examples. What kind of edits could it make?
They showed examples where transfusion could change the color of an object in a photo, add a new element to a scene,
Okay.
or even change the overall artistic style of the picture.
Wow. Just with text prompts.
All based on simple text prompts.
It's like having a personal AI artist,
It is.
ready to bring your visual ideas to life.
And it shows that transfusion isn't just good at making images and text separately.
Yeah.
It's capable of understanding the relationship between them
Right.
in a much deeper way.
Yeah.
It's bridging that gap between the visual and the linguistic,
Totally.
opening up all these new possibilities.
These are really groundbreaking stuff. It feels like a huge shift in AI,
It does.
where models are becoming more versatile, adaptable, and better at understanding the world like we do.
You've got it.
But with any new powerful tech, we have to think about both the benefits
Yeah.
and the potential downsides.
Right.
Are there any limitations to transfusion that we should be aware of?
Well, one is that the research focused mainly on static images.
Okay.
Expanding this to videos or other dynamic content would be an exciting next step.
That's a good point. And while transfusion showed a lot of potential in image editing,
Yeah.
it was only fine-tuned on a small set of tasks.
Right.
More research is needed to really explore its capabilities in that area.
Definitely. And as with any AI system, there's always the risk of unintended consequences.
Right, that's always a concern.
We need to be aware of the potential for misuse,
Yeah,
like creating misleading content.
absolutely.
It's important to have these conversations now as this technology continues to develop.
I agree. It's our responsibility to make sure that AI is used responsibly.
It is.
But let's not forget the potential that transfusion represents.
Right.
It's amazing what we can do
It is.
when we put our minds to it.
This research is a big step forward for multimodal AI.
It is.
It shows us that the future of AI is likely to be multimodal.
Yeah, it's not just about specialized models anymore.
It's about creating AI systems that can use different types of data,
Right.
leading to a more holistic understanding of the world.
I agree. It feels like we're on the edge of a new era of AI,
Yeah.
where models are going to be able to interact with the world more like we do.
I love that. As for the most exciting applications,
Yeah.
I see a lot of potential in areas like creativity and design,
Cool.
healthcare, and even scientific discovery.
Wow, that's a lot.
Imagine AI systems that can help us design amazing architecture, develop personalized medical treatments, or even help us unravel the mysteries of the universe.
Those are some big applications. The possibilities are truly endless.
They are. This has been a great deep dive into transfusion.
It has.
And this research is going to make a big impact.
Yeah.
We're really just starting to see what it can do.
So are we moving toward AI systems that see the world more like humans do?
That's the question.
Yeah. And what new and exciting applications will this unlock?
That's what I want to know.
This has been awesome.
Yeah.
It's clear that this is a big moment for AI,
Yes.
and we're really excited to see what happens next.
Me too.
For all our listeners who want to get into the details of transfusion,
Yeah.
we'll put a link to the full paper in the show notes.
Check it out and let us know what you find interesting.
Yeah. We'd love to hear your thoughts.
Definitely.
Thanks for joining us, everyone. Until next time, keep exploring and learning. It's amazing, we started by comparing transfusion to Da Vinci,
Yeah.
but it feels like something totally new.
It really does. It's not just mimicking us.
Right.
It's pointing to a new kind of intelligence.
Yeah.
Blending human-like understanding
Right.
with that machine power.
And for our listeners who are machine learning experts,
Yeah.
what are the big takeaways here? What makes transfusion so special for them?
It's a beacon for them, proof that true multimodality is possible.
Right.
It's about going beyond just one type of AI,
Okay.
embracing the real world where data comes in all sorts of forms.
Like transfusion is saying, stop making separate models for everything.
Yeah.
Let's create AI that learns across modalities, just like we do.
Exactly. And the possibilities for research, they're huge.
How so?
Think about medical diagnosis,
Right.
where AI could look at images, patient history, genetic data,
Yeah.
all at once to give more accurate and personalized treatments.
Wow. Or in scientific research,
Right.
where transfusion could help make sense of massive data sets with text, images, sensor readings.
Leading to those big discoveries in fields like climate science or astrophysics.
The possibilities are mind-blowing.
Yeah.
And it's not just about solving problems we already have.
No, not at all.
It's about new innovations, right?
Right. Imagine using this tech to create AI that designs personalized learning,
Okay.
interactive art, or even composes music that reacts to visuals and emotions.
That's like we're giving a powerful tool to the next generation of AI folks.
Exactly. And what they do with it, well, that's up to their imagination.
That's what makes me excited about AI's future.
Ew.
Transfusion is just the start.
Yeah, it's a glimpse into a world where AI isn't just a tool, it's a collaborator.
Working with it.
Right, to understand and shape the world.
This has been incredible. It's clear that this research on transfusion,
Yeah,
it's a big deal for AI.
it is.
We're so excited to see where it goes from here.
Me too. It's a fantastic time to be working in AI, and transfusion is a perfect example of the amazing progress we're making.
Absolutely. And for everyone who wants to dig deeper into the technical side of transfusion,
Yeah.
we'll link the full paper in the show notes.
Check it out. Let us know what you think.
We love to hear your thoughts and keep the conversation going.
Definitely.
Thanks for joining us, everyone. Until next time, keep exploring, keep learning, and keep pushing the boundaries of what's possible.